In our final video for today, we're going to do this last page of our notes. The directions say determine the area of each triangle to the nearest tenth. We learned two formulas. One was the area formula using side, angle, side. The other was using side, side, side. Side, angle, side, that was the area formula equals 1/2. And we do like side A times side B times the sine of angle C. But we don't have the side, or we don't have C, we have B. So what we can do is we can configure this and switch out to make this angle B, which would use side C. So we'd have 1/2 AC sine B, angle B. So we would use this formula for that one. Number 8, we would do that semi-perimeter Heron's formula. The semi-perimeter equals 10 plus 11 plus 17 divided by 2. Then the area would be that number times, and then all the differences of these. So let's see, 17 and 11, 28, plus 10 is 38, divided by 2 is 19. Then let's do 19 minus 10. Let's do 19 minus 11. Let's do 19 minus 17, and this would give you your area for that one. I do know that there's a couple of perfect squares that go into these, like 16 and 9 would be a perfect square, right? 8 times 2 is 16, 9 is a perfect square. I believe 16 times 9 is 144, so I believe the answer might be like 12 root 19 units squared. Why don't I finish this one? Let's do 1/2, side length A is 29, side length C is 24, times the sine of 101 degrees. It says round to the nearest tenth. Now here's the thing, I'm not going to round this to the nearest tenth. That's an exact answer. So no way, Jose, not going to do it. Can't make me. Exact answers are better. 0.5 times 29 times 24 times the sine of 101 degrees. This is the one I'm going to round. This is 341 point, so tenth, one decimal place. So it's 0.6 square units. Moving on to 9 and 10, we would use Heron's formula. We would use the sine formula. And last, our section says solve each triangle below and determine its area. So it's like a review of every single thing we did in its practice. So here goes. We have an angle and two sides, but none of the sides are across from this angle. This would be the law of cosines, and if it's the law of cosines, then I could figure out which one I would use, which area formula I would use. This would be side, angle, side. I'd actually use the sine area formula for this one, that 1/2 times BC times the sine of angle A, 1/2 BC sine A. For this one, I have an angle across from a side length. I would use the law of sines, and when I would get, that would generate a potential triangle, or maybe two potential triangles. This is the side that's across from this angle. This is the big side. There's no ambiguity on this one, so I feel relieved about that. Then I would pick whichever formula to use for my area formula. Maybe after finding the value of side C, I could do like A times, like 1/2 A times the value of C times the sine of 95 degrees and find the area there. That wraps up today's lesson. Good luck tonight. Your homework will be in the Delta Math. Might have some mixed practice and some connected triangles. Just be careful. If you start using the law of cosines, once you find a side or an angle, just be careful of that ambiguous case. If you do decide to switch to the law of sines, it's possible that there is more than one answer. They might, in Delta Math, continue using the law of cosines anyway. It wouldn't be a bad idea to do that. Best of luck. Let me know if you have any questions. After this lesson, we're gonna start to review for an assessment at the beginning of next week. Bye-bye. Good luck.